Today, we are diving into a totally new kind of AI. Seriously, this is a system that promises to go way beyond just matching patterns and into something that really looks like it understands. It's called HCNV-ColBERT, and yeah, it might just change everything we thought we knew.
So, let's just kick things off with a huge question. You know how for all their power you sometimes get the feeling that today's AIs don't really get it? I mean, they're amazing at guessing the next word in a sentence, but do they truly understand the meaning behind what we're asking? What if an AI could finally show its work and explain its reasoning every single time?
You see, the big challenge with most of the AI we use today is what everyone calls the black box problem. We feed a question in one side, an answer pops out the other. But that whole process in the middle, it's often a total mystery. Sometimes, it's even a mystery to the people who built it.
And this slide just lays it out perfectly. On the one hand, you've got the old way, traditional models. They work on statistics, right? Basically guessing that this word probably belongs near that word. They have no real clue where their answers come from. But then, on the other hand, you have HCNV-ColBERT. It was literally built from the ground up for total explainability, for actually comprehending semantics, and, this is the big one, for tracing every single fact back to its original source.
So how on earth does it pull this off? Well, this isn't just some tweak on an old model. Nope, it's a completely new semantic architecture. It's designed to build knowledge in a way that's structured, logical, and totally verifiable, right from the very beginning.
Okay, so the whole process kicks off with something called a semantic space type, or SST. Before the system even thinks about processing the information, it sorts every single relationship into one of 4 logical buckets. It asks, is this about things being near each other? Is it a sequence of events? Is one thing part of another? Or is it a defining quality? Just doing this first step makes it incredibly efficient.
After that, the system uses what it calls Canonical Pairwise Identifiers, or CTIs. The best way to think of these is like semantic Lego bricks. So a full idea like cat catches mouse gets broken down into its 2 fundamental parts. You've got the subject doing the action, which is cat plus catches, and then you have the action affecting the object, catches plus mouse. 2 simple bricks.
And now, we get to see what it does with those Lego bricks. This is where it gets really clever. The subject action bricks become the rows in this giant matrix, and the action object bricks become the columns. So you can see that row for cat catches right there on the left. And the magic happens right there at the intersection. When that cat catches row meets the catches mouse column, they just click. That intersection point is called a Canonical Triple Identifier, or a CTI, and that single point represents one complete verifiable fact. Each of these CTIs gets its own unique cryptographic hash. Think of it like a semantic fingerprint that's exactly the same for that single piece of knowledge, no matter what language you're speaking. Okay, so that's the blueprint, right? But let's see how this brilliant architecture actually holds up when you throw a complex, real-world question at it, one where you absolutely need accuracy and proof. All right, let's say we ask it to find treatments for COVID-19. First, it knows treatment is a process, so it immediately zips over to that sequence semantic space we talked about, completely ignoring 75% of its database. Then boom, it jumps directly to the row for COVID-19 plus treats. Now here's the crazy part. Instead of scanning everything, it only looks at the points on that row where data actually exists, which is a minuscule fraction of the whole thing. It finds intersections for drugs like remdesivir and Paxlovid, generates their unique CTI fingerprints, and then instantly traces those fingerprints back to every single source document that states that fact, whether it's the New England Journal of Medicine, the FDA, or the WHO. And to top it off, it then ranks those answers by how effective they are and how credible the sources are.
And how long do you think that whole thing took? To find the answer, verify it, trace it to the source, and rank it by credibility? 8 milliseconds? I mean, that is just unbelievably fast. Look, this isn't just a tiny improvement. We really need to put into perspective just how revolutionary this is when we talk about speed, efficiency, and just raw intelligence. We're talking about a system that is anywhere from 5,000 to 20,000 times faster than the traditional dense embedding models that most AI runs on. That's not just a leap, that's a whole new dimension of performance.
And here you can see it side by side. The traditional systems, they take anywhere from 50 to 200 milliseconds to give you an answer. HCNV-ColBERT, it's consistently hanging out in the 5 to 15 millisecond range. It's not even in the same ballpark.
This chart really just says it all, doesn't it? It's not a little bit faster. It is a fundamentally
different class of performance. This is what enables real-time intelligence on a massive, massive scale.
And all that speed unlocks some truly incredible superpowers. Because every piece of data has an explicit, locked-in meaning, you get complete explainability. Because facts are boiled down to that universal hash, it works across every language, seamlessly. It's built to be source-aware, ranking info by quality. And it's all possible because of that insane efficiency. It never, ever wastes time processing data that isn't relevant.
Okay, now hold on, because this is where it gets really mind-bending. The architecture can work across 3 totally separate but interconnected knowledge environments. You've got the CCC, which is basically all of global public knowledge. Then there's the SSS, for an organization's specialized internal knowledge. And finally, the PPP, which is your own personal context and data.
Let's make that real, because it sounds abstract. Imagine a vet asking the system why her cat, Luna, isn't catching mice anymore. The AI doesn't just do a web search. It fuses knowledge from all 3 sources at once: the vet's own personal notes and videos of Luna from her private PPP, the clinic's entire database of similar cat cases from their shared SSS, and all the latest global veterinary research from the CCC. It brings all 3 together to give a diagnosis that is perfectly tailored and completely source verified. I mean, that is a level of contextual intelligence we have just never seen before.
So what's the big takeaway here? It means the future of information isn't just about getting quick answers. It's about getting answers you can actually trust, that you can understand, and that you can verify yourself. The future, it seems, is explainable.
And the potential for disruption here is just immense. I mean, think about search engines that rank results by source credibility instead of just counting links. Imagine enterprise systems that can unify every bit of a company's knowledge instantly across every language they operate in. Or tools for scientists that automatically pull together evidence from thousands of research papers and even flag when they contradict each other. The applications are just transformative.
As the source material itself puts it, this isn't just another incremental update. It is a fundamental breakthrough. It's a true paradigm shift, moving away from just statistical pattern matching and into the world of genuine, provable semantic comprehension.
Which really just leaves us with one final, fascinating question to think about. For the very first time, we're looking at an AI that can actually show its work, prove where it got its information, and explain its logic. So, if you had a tool with that level of trust, with that level of transparency, what would be the very first problem you would ask it to solve?